Today I am going to talk about electric field due to system of charges. System of charges means large number of charges, and all these charges producing electric field at a given point. At a given point we shall be putting some test charge, and we will be finding out how much the total electric field acting on the test charge due to the so many charges placed in the system. Here we are considering all charges are placed in the vacuum. Even we can study all charges placed in the medium as well as. But today's I am going to develop the electric field due to system of charges placed in the vacuum and the collective, the net electric field due to all charges on the test charge. For that, we are going to use the Coulombs law, and we are going to take the help of principle of superposition. And if you wish to find out electric field due to system of charges placed in a medium, then only thing is changing, that is a permittivity. Permittivity of free space is replaced by the permittivity of the medium. More and expression for both the free space and for the medium is remaining the same. Only the permittivity will be changing. While obtaining expression for electric field due to system of charges, we use one principle of superposition, another is a Coulombs law of electrostatics. Let us have a quick revision what exactly the principle of superposition and what exactly the Coulombs law is. What is the principle of superposition? When large number of charges are present in a medium and the force, you are calculating force on any two charges. Example, if you are calculating force on Q1 due to Q2, and the force between Q1 and Q2 not affected due to the presence of Q3, Q4, etc. So the total force, if you wish to find total force, then you have to find out vector sum of all the forces. And so this is what the principle of superposition. Let me read the definition one time for you. When n number of charges such as Q1, Q2, Qn placed in vacuum or in a medium, the force on any one single charge due to number of charges is the vector sum of all the forces on that charge taken one at a time. The individual forces are unaffected due to the presence of other charges. Here let us have a quick revision on Coulombs law. Here I am having the Q1 charge, another is the Q2 charge. The force between Q1 and Q2 given by 1 upon 4 pi epsilon naught Q1 Q2 upon R square multiplied by unit vector. And here the expression for the force on Q2 due to Q1 and force on Q1 due to Q2. These are the two expressions. So whenever you find out F21, then you need to multiply by unit vector R21. And whenever you are calculating force 1-2, then you need to multiply by unit vector R12. So these are the two expression. These are developed on the basis of the Coulombs law. We shall be utilizing this expression while finding out electric field due to the system of charges. Now let us have a quick revision about the electric field. Suppose at O there is a O origin and point P. At origin we place the charge Q, and distance P is at a distance of R. Then denotation of electric field is the E of R. E of R nothing but given by 1 upon 4 pi epsilon Q upon R square multiplied by unit vector in the direction of vector OP. And so this is the basic formula for electric field produced due to the given charge Q. Even this formula we shall be utilizing to produce the electric field due to the system of charges. How this expression has come? Because E of R, the definition of E of R nothing but force per unit, the Coulomb force per unit charge. So that is 1 upon 4 pi epsilon naught Q multiplied by Q upon R square into R cap divided by q. Q get cancelled here. Then what do you obtain? You obtain is that E of r equals to 1 upon 4 pi epsilon q upon r square multiplied by r cap. So this way the expression for electric field has been obtained. You can even visit my video. Specially, I have developed the expression for electric field for a single charge. So from that video, you can have the total detailed explanation. Now consider some charges like Q1, Q2, Q3, Q4, Qn, and consider a point P. At the point P, we want to find out how much electric field due to all these charges. Now, electric field due to the charge Q1 is given by this vector and it is a E1. So, electric field due to the charge Q1 at the point P is given by E1. Similarly, electric field due to the charge Q2 at the point P is E2. You see, there is an arrow mark. Arrow mark means it is a vector. And electric field due to charge Q3. Electric field due to charge Q3 is E3 and it is at the point P. Similarly, electric field due to the charge Q4 is E4. Now, electric field due to charge Qn is En. Thus, electric field due to the first charge is E1, second charge is E2, third charge is E3, fourth charge is E4, and so on n number of charge. So last charge, the electric field of charge Qn is En. Here, this is nothing but vector R1p. This is nothing but vector R2p. And this is nothing but vector R3p, and this is nothing but vector R4p, and this is nothing but vector Rnp. Once again, the vector directed from the charge Q1 to P, that is vector R1p, and the vector directed from charge Q to P, that is the vector R2p, and from the charge Q3 vector R3p, and vector directed from charge Q4 to P, that is the vector 4p. Similarly, vector directed from the last charge is the vector Rnp. Since we are finding out electric field at point P at a distance r, therefore the denotation is a E1r. With respect to distance r we are finding out, therefore it is a E1 of r, E2 of r, E3 of r, and E4r of r. Similarly, En of r. So the net electric field at a point P is E of r equals to E1 of r plus E2 of r plus E3 of r, and so on till the last charge, that is the nth charge, En of r, where E1 of r equals to 1 upon 4 pi epsilon naught Q1 upon R1p square multiplied by unit vector R1p. This is the electric field due to Q1 at the point P. Similarly, electric field at the point P due to the charge Q2 is equals to 1 upon 4 pi epsilon naught Q2 upon R2p square multiplied by unit vector R2p. Similarly, the electric field due to the nth charge, that is the En of R, equals to 1 upon 4 pi epsilon naught Qn upon R Np square multiplied by R Np cap. Now, by according to principle of superposition, electric field at R due to system of charges is given by addition of all the charges. Addition, that is a vector sum. E of R equals to E1 of R plus E2 of R plus E3 of R plus and so on En of R. That is equals to 1 upon 4 pi epsilon naught Q1 upon R1p square multiplied by R1p cap plus 1 upon 4 pi epsilon naught Q2 upon R2p square into unit vector R2p plus and so on 1 upon 4 pi epsilon naught Qn upon Rnp square multiplied by Rnp cap. This is equals to, now what you can do, you can take 1 upon 4 pi epsilon naught common, then Q1 upon R1p square multiplied by R1p cap plus Q2 upon R2p square multiplied by R2p cap and so on Qn upon Rnp square multiplied by Rnp cap. Now in summation form it can be written as 1 upon 4 pi epsilon naught, and it is starting from the first charge and up to the nth charge. So summation I is equal to 1 to n, last charge is n, and here is a Qi divided by R I P square multiplied by R I P cap. This is the required summation form. It is nothing but E of R, that is the electric field, the total electric field at the point P due to all the charges, and it is a vector quantity. E of here is a vector quantity. Now summarize the things. We had the charges Q1, Q2, Q3, Qn. First we obtain the expression for electric field due to the first charge, second charge, third charge and the nth charge. Then we added all the electric fields and converted into the summation form, and we got the expression for electric field due to system of charges, and it is in the vector form. That means this is not the end. After this one we have to individually calculate the vector sum of all the electric field, then only we would be getting the final answer. That's all in this video. I hope that your concept regarding electric field due to system of charges has been cleared. You need to do practice, writing practice, at least 2 to 3 times without seeing. Then only it will go to your memory. Otherwise, listen from here and remove from this side. That should not happen. So practicing makes perfect. In the next video, I am going to talk about electric flux. Till then, wish you good luck, all the best. Before saying goodbye to you, I request you to like, share and subscribe the channel. If you share with your friends, we will reach to more and more needy people, and our hard work and our efforts in making videos will be useful to somewhere for some needy students. Wish you good luck, all the best. Meet you again with next video.